Okay, we will be covering matrices, transformation matrices, few questions and examples from past papers, how to handle those parts. For now, I'll only solve the parts related to matrix. Now look at this question. It says that find the matrix representing the transformation that maps Q onto R. So first you have to analyze that Q onto R is actually a reflection in the line y is equals to 0, or you say x-axis. So if you've gone through the first video where I've explained that always consider this basic block, and this is x1 and 0, this is x0 y1, always this is always the case. Consider these 2 points, point A and point B. Now whatever the case is, this is actually the reflection in x-axis. Now you perform the reflection part on this. So let me please switch the coordinates A and B. We'll always talk about A first and then B. So now I'm going to reflect this given basic block in x-axis. So when I reflect this, you see that A never moves, it stays at its position, and B comes down to this point and becomes x0 and y minus 1. So whatever happens to A, you write that first. Whatever happens to B, you write that at the second place. So A resulted as 1 0 after the transformation. B resulted as 0 minus 1. 0 minus 1. So the matrix representing the transformation which maps Q onto R was a reflection in x-axis, and reflection in x-axis is represented by this matrix. Let's move on to the next example. Write down the matrix representing the transformation. Now look at this question. The triangle A is mapped onto triangle C by a rotation, center, origin through 90 degrees anti-clockwise. So this is center and 90-degree anti-clockwise. I'm not focusing on this transformation right now. Let me just quickly draw the answer. Anti-clockwise, this and this point would appear here. So it would look like this when you solve it. We'll go into detail in the next video. So write down the matrix representing the transformation. This is 90 degree. This is 90 degrees anti-clockwise. Again, every time you face this question, just draw this basic block. x1, y0, x0, y1. This is A, this is B. Now what we are going through is 90 degree anti-clockwise. So we rotate both of these one by one. B will come over here 90 degrees anti-clockwise, and this becomes x minus 1 and y0, and A comes at this point. Now what is the result of A in this transformation? Result of A is now x0 y1, and result of B is minus 1 0. You do not have to memorize this. You cannot memorize this. Just understand this logic, and this is it. 90 degrees anti-clockwise rotation about the origin is represented by this matrix. Few more questions. Triangle A is mapped onto triangle C by a transformation T. And what is T? T is a rotation center of origin through 270 degree clockwise. So 270 degree clockwise actually means 90 degrees anti-clockwise. You can go about any method, answer would be correct. So this is 90 degrees anti-clockwise. We just did that, so I'm skipping that part. The diagram shows the triangle A, B, and C. These are the three triangles. So find the matrix representing, focusing only on the matrix part. Find the matrix representing the transformation that maps A onto C. Now A onto C, analyze that this is the reflection in y-axis, or x is equals to 0. So we go through this. We always draw our basic block. This is x1, y0. x0, y1, label this A, label this B. You don't have to go through this labeling. It's just for my ease to speak. So now I am going to reflect it in the y-axis. this point A right here will appear here when reflected in y-axis and becomes x minus 1 and y0. B stays there, known as the invariant line. So when A jumps over here, what happened to the coordinate which was on x-axis, always write that first. It became minus 1, 0. What happened to B? It never changed. That is 0, 1. So the matrix representing the transformation, which is a reflection in y-axis, is this. Moving on to the next question. Now, this question is related to matrices transformation. You only need to know how to read them, and performing the question or solving the question is basically depending on matrix knowledge. Now, T1, T2, and T3 are three different type of transformations, such that T1A, how do you read it? You read it from right to left. You read it from right to left. A is an object. You applied a transformation T1 and it resulted in B. For example, if I say that I have R as a transformation and applied on A, and I call R as a reflection in y-axis. So when I will apply R on A, the result would be, if I name it B, the result would be this. So we read from right to left. To A, you applied R and it resulted in B. Now look at this question. It says whatever it is, on triangle A, you applied T and it became B. And on A, if you apply T2, whatever T2 is, it became C. On C, if you apply T3, it became B. The vertices of triangle A are already given. The matrix T1, now one by one, now it's the examiner started with T1, is given 2, 2, 0, 1. Now this is 2, 2, 0, 1. A is 1, 0, 0, 1, 1, 3. So you see 1, 0, 0, 1, 1, 3 in this order. Now this is simple matrix multiplication, row into column. So 2, answer is 2 into 1 is 2 plus 0, 0 plus 2, then this is 2 plus 6. First part is 0, 0 plus 0, 0 plus 1, 0 plus 3. So the final answer of this matrix multiplication is 2, 2, 8, 3, 1, 0. Examiner is not demanding that what this actually is, and not demanding the drawing of the image. The matrix that represents T2, matrix is given. Find the inverse. Again, matrices knowledge. Determinant is 2 into 1 minus 0 into 0. So determinant is 2. So 1 over determinant into adjoint. Place change and sign change. So this is your inverse. The matrix that represents T3 is M. So we have to find M. I'm going back to the question to see the story what actually T3 is. To find this T3, I can substitute few values. You see this C right here? If I write T2A in this place, so this becomes T3. I'm substituting this C with T2A is equals to B. So you notice few things that we know what B is. B is this. So we have B, first thing. A, T2, we have T2 in question, we have A, so just substitute it and solve for T. Remember the knowledge of matrices, and if you are appearing in 2025, you won't be facing this problem. Matrices is excluded in this year particularly. So if you are appearing in 2024, you will have to go through this. And just remember the step that if you have matrix A, B is equals to C, when you take A on the right hand side, this is A inverse C. A was on left side of B, keep it on left side of A. Few questions myself for you. So consider this A and B. If the examiner asks you to find the matrix for reflection, this is actually reflection. If you look look into it closely. A, B is reflection in y is equals to minus x. So if the examiner demands this matrix, every time just draw this. This is x1, y0, this is x0, y1, and now you have to reflect it in y is equals to minus x. So draw this line right here. Now this point which was on x-axis will come here. This point which was on y-axis will come here. The result of x-axis would be x0, y minus 1, and result of y-axis would be x minus 1, y0. So you always write where this point A goes first. So this reflection would be represented by 0, minus 1 and minus 1, 0. One thing. And the other part for this question is this: the triangle A is mapped onto triangle C by a rotation of 90 degrees clockwise. So I'm going to rotate this 90-degree clockwise. This point about the origin. This point will appear here. This point 3 will appear over here. And the third point is this. And then the demand is to this triangle B is mapped onto triangle C by transformation. So this is reflection in y-axis, which we've already covered. So I'll skip it for now. And this would be enough. Okay. Triangle A is mapped onto triangle C by transformation represented by this. Matrix is already given. So A is mapped onto C. How you have to read it? The transformation is applied on A and the result is C. So what you'll do is calculate the coordinates. The transformation is 1301. This is 1301. For A, copy the coordinates of A. You're given with A as well, and you can read it from the diagram. So this is 0.5 and 1, 0.5, 1, then 1, 2. So this is 1, this is 2, then you have 2, 2, 2, 2. Just multiply row into column and you will be good to go. Last question for today. It says the triangle A is mapped onto triangle B by a single transformation K. A is mapped onto B. Now be thoughtful and see that it is a 90-degree anti-clockwise rotation about the origin. So basic triangle 1, 0, 0, 1, 90 degrees anti-clockwise. This point will come over here, this will come over here. So the point which was on x-axis became 0, 1, and the point which was on y-axis after the 90-degree anti-clockwise rotation became minus 1, 0. Oh, we have one more question. Triangle A is drawn on the grid. Transformation P is represented by the given matrix, and I can see that this is enlargement with scale factor minus 2. And how's that? Whatever this is 1, 0. This is 0, 1. If I go through the enlargement part, this would become, this moves by how much? 2 times, 3 times, 4 times. So I can say it moved k times. So what happened to the point on x-axis? It became k0. What happened to the point on y-axis? It became 0k. What is k? K is equals to scale factor. So scale factor is minus 2. So I can see through it that it is an enlargement with scale factor minus 2. So P maps triangle A onto B. So this triangle A is mapped onto triangle B. There are two ways. You can just use the enlargement of minus 2 or use this matrix. Draw and label triangle B, and how you go through the matrix part, how you do it. So this is it. Copy the coordinates of A in any order. I'm starting with this x2, y1, then this one x3, y1, the third one is x2, y3. So in any order, multiply row into column and you'll have the coordinates of B. This is it. Thank you so much for watching. Hope it helped you. Take care. Allah Hafiz.